How did you go? Tricky, wasn't it? Yeah, there's quite a lot to it, and I'm sure you had trouble with some of those functions. But take heart, because I mean, this is the first time that you've ever had to write your own functions, and everybody makes mistakes the first time. You get the hang of it. You start to get the feel for what a function is like, and what it looks like, how you write them, and so on. So I know you will have had trouble with that. But anyway, here are the solutions that I'm going to provide. Your solutions may be completely different to this, but this will give you hopefully some ideas as to how you could proceed if you got stuck. Okay. Okay, here we are back in database.c. Okay, so I'm going to walk down from the top now and look at each of the new functions that I've created in turn and check that they all do what we think they're supposed to do, and then we'll have a look at the main and see how to use them all. We'll start with the simplest function, the trim new line function. Now, you pass it in a string. Here's the string that you pass in. Now, this function is going to modify this parameter. This array is going to get changed, or rather the elements of the array are going to get changed. In other words, the individual characters are going to get changed. One particular character is going to get changed, the character that contains the new line, if there is one. So we have to actually test whether there is one. We know that if there is one, it's going to be in the very last position of the string. In other words, it's going to be the one just before the length of the string. So find the length of the string, remove one from it. If that is a new line character, then take that same character and replace it with a null, thus effectively shortening the string. So you'll have a string that's terminated by 2 null characters, but that's okay, one's enough. Moving on down. Notice that that trim new line has no return statement. It does not try and return anything. It doesn't try and return the string once it's completed and once it's processed the string. Another very simple function. This one again does not have any return statement in it. It is simply prompt the user with a string and then read a character from the keyboard. So here is the string that the user will see, and this prompt does not get modified at all by the enter function. Even though enter function could have modified the string, it chooses not to. It simply displays it on standard out. In other words, it does a put s on it, flush the keyboard, and do a get sharp. Pretty straightforward. And we're going to use that a couple of times in our main program. Now, slightly more complex than that. It's the same idea, but this time we're actually going to return an integer. So I can even put that it's got an integer return type. Even though that's implicit, even though it's going to be an int, even if I don't have the word int there, it's still an int. It's nice to put the word int there just to know, just so that everybody knows that it is actually going to return an integer. We can modify the comment to make it really clear and say if the y or the y is given, the function returns 1, and then n or n gives 0. Okay, so it's good to put that in the function's comment, so that people who come and look at the function who want to use it in future will know exactly what it does. Okay, now similar to the enter function, we have a prompt, and the first thing we're going to do is, well, we're going to display that prompt. So let's have a look at that. Oh, and we're going to read an answer as well. And this is going to be a loop, because they may actually type an incorrect answer. They may put the letter P or the number 3 or something like that. So we put out the prompt, display the question. I've written mine in such a way that they don't have to put a question mark on the end, and I will do that for them. I'll take their question and I'll add a space and then a yes or a no in brackets and then a question mark and then another space. I'll put all of that on the end of their question for them so they don't have to do it. Just a little helpful thing that I'm doing for them. Then read a character from the keyboard. Then process it. First convert it to uppercase. Then, if it is a yes, return 1. If it is a no, return 0. Now, there's a few things here that you won't have seen before. The first is that you're calling the return statement from the middle of the function. There is no return statement at the end, and there doesn't need to be. I mean, I could have put a break at those points. I could have put a break there and a break there, and then down here I could have put return and then some value based on whether answer was a yes or a no. But I don't need to, because I can return immediately from here. Now, I don't know if you knew that you could do that, but you can. Notice also that there's no else here. I don't need to put an else. I could put an else, it would still work, but I just don't need one. See if you can figure out why you don't need an else in this particular instance. Now, if they don't return that and they don't return that, I could put an else here too. But again, I simply don't need an else. It's not necessary. I can get away without it. It will still work in exactly the same way. Again, prove to yourself that that is the case. So you can pretend that there is an else here. If you like, if it makes you happy. So else, if it's neither a yes nor a no, then print out the error message. Okay, I'm going to remove that else because I don't want it there. And we simply go around the loop and do it all again. Display the question, scan for another answer, and process the answer again and again and again. Notice that if the user ever does answer a Y or an N, then the function will return, which will of course break the loop. So it's not truly an infinite loop. It's a forever loop, but it's not an infinite loop because there is a way to get out of the loop. In fact, there's two ways to get out of the loop, right there. I guess the proof of the pudding's in the tasting. We'll see if this function works when we run the program. Now, this is actually a much simpler program, much simpler function. Read integer, read an integer. And again, we need a prompt. That is what we're going to prompt the user for, like please enter the number of tracks or something like that. So we'll put that out on the screen, flash standard input, and then we'll read an answer. Here is our answer, and then of course we're going to return that answer. So it's a pretty classic, simple function. And float is exactly the same. It's all the same except that the function returns a float and the answer that they type in is a float. So we do a %f instead of a %d. Again, it's exactly the same. Okay, now read a string. This is slightly different because remember, functions cannot return strings. However, functions can modify their parameters if those parameters are arrays or strings. So, again we have a prompt, but rather than having a return value of some kind of char here, which we can't have, we simply create another parameter, which is the answer here. Now, I'll explain that third parameter in a second. Again, display the prompt. Again, flash standard input. Now, do an fgetS on the answer. That is where fgetS reads its answer into. And remember, you must specify to fgetS how big the string is that you're reading into, so it knows when to stop, so it doesn't crash the program. That's quite important. So, if you're going to specify that, you must get that from somewhere. Now, readString can't possibly know how big it is. It cannot do a size of. It cannot do this. It cannot do size of answer. Well, it can do it. The program will compile. It will even run, but it just won't work because, as you can see here, answer doesn't really have a size. There's no number inside the square brackets there. So that will not work. It's not possible for this function, readString, to know how big the array is. So we have to tell it. And the only way we can do that is to pass that in as another parameter, which is what I've done. Now, you may have chosen to do the scanf version of this. Instead of using fgetS, you may have used scanf. And that will be fine, other than the fact that your string will have a maximum size. The answer is going to be passed in from somewhere, and that somewhere will be an actual declared string. Let's say it's 30 characters. So you'll be passing in a 30-character array. So you'll be reading the answer into a 30-character array. Whether you're using scanf or getS, it doesn't matter. You'll still be reading into a 30-character array. And if the user types in 50 characters on the keyboard, which is certainly more than 30, you'll probably crash your program. If you don't believe me, try it. So I would assert that this is the more correct way of doing it because this will not crash the program. Anyway, that's completely up to you. Finally, we trim the new line from the answer, and that's the function that we saw earlier. Finally, output. We must pass in several things. We must pass in the title string, the artist string, the number of tracks, the integer, which is a boolean that tells us whether it's an album or a single, and finally the price. And that's pretty straightforward. Just print all that detail out. This is just a cut and paste from where it was before. Okay, so that's pretty straightforward. Now we get down to the main. You'll find that the main is much smaller than it used to be. Again, declare all the variables. Not all the variables. We don't need a type variable anymore because the only place the type is ever used is there in the yes/no function. We'll call it answer this time. So back down to main. Here we are back in main. Okay, again we do our little printf. Now we do the loop. Oh, we ask them the yes/no question. Now, we could write this like this. We could say if that equals 0, because yes/no will always return a 1 or a 0. So we could say if you don't have any more CDs to enter, then obviously the answer will have been no, which means we'll get a 0 back from here. And remember that that is exactly the same as putting not there. If you can think of yes/no as a boolean, then you can put an exclamation mark in the beginning of it to treat it as the not version. In other words, if yes/no returned a 1, then not yes/no will be 0, and vice versa. If yes/no returns 0, then not yes/no will be 1. So whether you understand that or not, you will hopefully agree with what I said before, that putting the exclamation mark there is exactly the same as putting equals 0 there. And hopefully that is quite easy to read for you. But when you become an experienced C programmer, you'll find that that is just as easy to read. It just says if not that. So if they answered no, then that's when we want to break. Okay, please enter the details of the CD. And now we just simply read all the details. And notice we've only got essentially 5 lines of code now. We don't have all those printfs and scanfs and fflushes and all those things. It's now very, very simple. We do a couple of read strings, and we pass in this. Now remember, we're dealing with 2-dimensional arrays here. Title, I'll go back up, title is a 2-dimensional array. We have, or if you like, it's an array of strings, and each string is of course an array in its own right. So this is now one string. If we've got a 2-dimensional array, then that is of course one string, and that is the size of it. Remember, we have to pass in the size to read string as well. And do exactly the same for artist. Much simpler. We tell readInt what question we want readInt to ask for us, and it will pass back a value which we can then put into tracks, or at least this particular track. And the same for album and the same for price. Notice that with yes/no, I don't have to put on the end space, brackets, y/n thingy, question mark, space, because the function will do all of that for me, so I can just leave that out. I know that's a little bit inconsistent, but I just wanted to show you that it's possible to do that. Check if we filled the array. Now this is an interesting line here. This is the use of that enter function that we wrote. Enter simply prints out a string. Now, what I want you to see here is I've actually got one string here, and I've got another string here. You'll have to agree those are 2 string literals. So what's between them? Well, I've just put them all both on the same line, and you'll find that there's just space between them. And in C, I've told you that it's perfectly okay to have lots of space between things, lots of spaces or tabs or new lines, and it's all just the same as having one new line or one space like that. Now, I haven't told you this before, but C actually says that if you have 2 contiguous string literals, and that is one string literal, and then we have another string literal here, and they're next to each other, that's what contiguous means, they're not separated by anything, they're only separated in this case by a space, then C will treat that as if they were one string literal. In other words, they were joined together. C will automatically concatenate them together for you. And I'm talking about string literals. I'm not talking about, if you've got a first name. Let's try that here. I'm not saying if you've got first name, if name is a string and address is also a string, you can't just put them together like that and expect them to be concatenated as in what strucat does. That will not concatenate them together. The reason is because they're not string literals. Now if you did this, that would certainly concatenate those together, and what you would end up would be name, address. It would be exactly the same as that. Those two lines, that one and that one, give you exactly the same thing. They give you a single string literal, which is, 11 characters long. So just know that about C. C will do that. The compiler will do that. It will concatenate two contiguous string literals. So just because it's gone on to another line and I'd rather keep it nice and visible, I've actually broken a string up into two strings, which, from what I've said before, makes no difference to the compiler whatsoever, because I haven't put any comma between them or anything like that. Notice I have not done that. That is not two contiguous string literals. That's a string literal followed by a comma, followed by another string literal. However, that is two string literals, and so the compiler treats them as one long string literal. So essentially you've got one long string with a new line character halfway along it. So enter will actually print that whole thing out for us, and then it'll ask us to press enter to continue, and which we'll do that and we'll move on. Finally, we output all the details of the CD. We tell them what we're about to print, then we print the details, and then we call our little enter function again, press enter to see the next set of details, and that's finally how we exit the program. We do exactly the same thing. We call the enter function once more. Okay, there's quite a lot to it, as you can see. Let's just check the header file. I want to make sure that's okay as well. Here's the header function, the header file, and here's all the prototypes. There they all are. Now those are just copied and pasted lines from the other .c file, and I've just made sure that each one of them begins with the type, because that is a full prototype. You must have the type there for the prototype to be complete. You can't just leave it out. In other words, if I did that, even though it's implicit that yes, no is an integer, with a prototype you have to be explicit. You actually have to put it there. So that is my header file. Anyway, back to the .c file. Let's compile it now. Okay, no errors, and run it. Have you any more CDs to enter? Okay, now that's the yes-no question at work. So let's see if that's actually behaving itself. Let's enter things that we're not allowed to. Okay, well it seems to be certainly prohibiting us from getting away with entering something wrong. So let's say yes, I do have some more CDs to enter. Okay, so we're off and running. Now, title, where it's asking us for the title. Now that is the read string function at work. So we'll type in something. We'll type in Love Over Gold. Artist, again, that's read string at work, and that's Dire Straits. Number of tracks, now that's the read int function at work. That's got 5 tracks. Is it an album or a CD? Yes or no this time. It's not an A or an S, it's a yes or a no. So yes, it is an album, yes. Retail price, let's say $9.50. And have you any more CDs to enter? No, that'll do. I just wanted to see whether the input function was working. And there we go. The output function is also working. Most excellent. Press enter to exit the program. There's that little enter function at work. Press enter to exit the program. It's done that. Now it's waiting for me to press enter, and it's working. Okay, good. So, look, I know there was a lot in that. I've turned what was quite a straightforward program now into quite a complex program. I've introduced complexity by introducing all these new functions. I think you'd have to agree with that. So you might think it's a step backwards. Well, in one sense it is. if I was not an experienced C programmer, I would consider that a step backwards, because many functions are much more difficult to understand than one function. However, I am an experienced C programmer, and you guys will be at one stage as well. And all experienced C programmers are quite comfortable with multiple functions. In fact, they expect them. In fact, they would be very surprised if they came in and found there was just one function, a great big main. So yes, I have increased the complexity, but I have also increased, I believe, the readability and maintainability of the program, because I have broken it up into small, discrete, modular chunks. Each chunk has a very simple purpose, to do one specific task. And then at the main, right at the end, I've arranged those tasks in a particular order and got them all done. I've even used some of them twice, like the yes-no function. I've used that, I think, twice, and the enter function, I've used that 3 times. The read string function, I've used that twice. So I've got some reusable code here, which we didn't have before. So I would assert that I've actually made the final program slightly smaller, because I've reduced the number of lines of code that I have. Well, I've got certainly got more comments, but you can see I've got 204 lines in this file. You can see that just down here, which is more than I used to have, but the actual lines of real code, the actual lines of code that do things, there's going to be less of those. I can almost guarantee that. Okay, so that's functions. Let's move on to the next chapter now, which is called structures.